Okay, let's now evaluate some radical expressions that contain variables. Let's do some real algebra. So if you look here at my first expression, I have the square root of x to the 12th, y to the 14th. The first thing I want you to notice is there's two terms here inside the radical that are connected by multiplication. So what we can do is we could technically rewrite this as two radicals, just like we've been doing for division. When there's a fraction inside a radical, we break both the numerator and denominator into it. So I'm going to rewrite this just so you can see this really means I'm doing the square root of x to the 12th and the square root of y to the 14th. First thing, we're doing a square root, which means I have to have a perfect square. For a variable to be a perfect square, you must have an even exponent. I have an even exponent, 12. I have an even exponent, 14. I'm good to go. These terms are perfect squares. So now the rule of thumb is real simple. Square root means to divide the exponent by 2. What times itself is x to the 12th? Well, that would be x to the 6th. Because if you remember your rules, when you multiply variables, you add exponents. And x to the 6th times x to the 6th would be 6, and 6 is 12. So that's why we're able to divide that in half. So what is the square root of y to the 14th? That's right, 14 divided by 2 would be 7. So we'd write y to the 7th. Because these two terms are connected by multiplication, when we take the square root of each, their terms are still connected by multiplication. So we would say this answer is x to the 6th, y to the 7th. Now, do we need to rewrite this as two separate radicals? No, I just want you to understand is if you're connected by multiplication, you could technically break it up. Now, we have to be careful. Look at our next expression. We're doing the square root of 100 z to the 20th. Again, we're doing a square root of a number 100, and then we're doing the square root of z to the 20th. So technically speaking, I'm going to write that. We're doing two steps here. Here's where the problems come in. I just taught you a rule how to do the square root of a variable. Don't apply that rule to a square root of a number. This is a number, 100. To do a square root of 100, we have to make sure 100's a perfect square, which means is it on the perfect square list. So now I got to recite my perfect square list. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. Yes, 100's a perfect square. What number times itself is 100? That's right, it's 10. Majority of you are going to sit right here and tell me 50, because you're going to divide that number by 2. And that's not the rule. To do a perfect square, to do a square root of a perfect square that's a number, you have to go off the list. Now we're doing a square root of a variable z. It's z to the 20th. Well, now we can do our new rule. The rule is to do a square root of a variable, you take your exponent and divide it in half. So if I have z to the 20th, half of that would be z to the 10th. And that is correct. Z to the 10th times z to the 10th would be z to the 20th. Because when you multiply letters, you add the exponents. So the square root of 100, z to the 20th, is 10z to the 10th. All right, now we're going to do a cube root. If we understand, cube root means we don't divide by 2. Cube root means we're making groups of 3. So cube root means is to divide the variable's exponent by 3. B to the 12th means there's 12 b's. If I'm cube rooting, I want to group those 12 in groups of 3. How many groups of 3 can you get out of 12? Well, that's right, you can get 4. So the cube root of b to the 12th is b to the 4th. Then I want to do the cube root of c to the 15th. Well, that will work. Both 12 and 15 are perfect cubes. How do I know they're perfect cubes? Because these exponents are multiples of 3. Think of your multiplication tables. 3, 6, 9, 12, 15. So these exponents are multiples of 3, which makes these terms perfect cubes. If these terms are perfect cubes, you can cube root them. Cube rooting means making groups of 3. How many groups of 3 can you get out of 15? Well, that would be 15 divided by 3, which is 5. So we'd write this as c to the 5th. Because both these terms are connected by multiplication, when I cube root them, our answers are connected by multiplication. All right, one more expression. I'm going to do the cube root of negative 27a to the 21st. So now we're cube rooting a number and then a variable. To cube root a number, we got to go off the cube root number list, which you have to have memorized. So your perfect cube numbers are 1, 8, 27, 64, 125, 216, 343, 512, 729, 1000. 27 is on the perfect cube list. Now, we talked about this. You can cube root a negative number. What number do we multiply 3 times to give us negative 27? That would be negative 3. Now we're going to do a cube root of a variable. To cube root a variable, we're dividing. We're saying right now there are 21 A's, and I want to put them in groups of 3. How many would be in each group? 21 divided by 3 means there would be 7 A's in each group. So the cube root of negative 27a to the 21st is negative 3a to the 7th. So be careful. Square rooting and cube rooting numbers, you're going off your cube and square list. Square rooting and cube rooting variables, you're dividing either by 2 or 3. See you in the next video.